with that, I just need to let you know. If there was anybody else in your office that was unable to attend, we can definitely share the recording with them as well. Since we have quite a few people on this webinar, we will have everybody muted and we'll handle all the questions through the chat box. So if you have a question anytime during this session, please type it into the chat box. And we will stop about 3 times throughout the webinar and review and answer the questions. Just in case we have too many questions, we do want to be respectful of everybody's time that we've allotted here. So if we do end up with too many questions, we'll go ahead and make a review and email it out to all the participants. Now I would like to introduce you to the 2 guys that will be running the show today. First is Alan Anaya. Alan is a senior sales engineer out of our New Mexico office. He has 30 years of HVAC experience, from customer air handler design to engineering manager at ECCI to outside sales with Veritech. Alan has been involved in ASHRAE for the better part of 20 years, and he has served on the New Mexico board as well. Dan Hani is a sales engineer and is our resident educator based out of our Phoenix, Arizona office. Dan has been in the HVAC industry for 35 years, starting as an estimator at Norman S. Wright Company. From estimating, Dan moved into contractor sales until he began the new millennium, filling a new role as Air Specialty Products' first outside salesman. Working at ASP in 2008, Dan took advantage of an opportunity to move into engineering sales and quickly became a promoter and presenter of high efficiency HVAC systems. In 2016, Veritech Solutions approached Dan to become our advocate and educator of high performance HVAC products, innovative system designs, and applications. So Dan and Alan, I will turn it over to you now.
Well, thank you so much, Kelly. Appreciate that. And thank you for all of you for attending today's presentation. First of all, just a little bit of, about me. My background is somewhat unique in the industry. I actually earned my Bachelor of Finance degree from the University of London in sculpture and a master's degree in sculpture at Boston University. However, I got into the industry as I paid through my way through college working in a sheet metal shop, and the parent company of that sheet metal shop, Metal Form, was Norman S. Wright Company. And upon graduation, I got a position as an estimator at Norman S. Wright and moved into the industry. So, and this is what I've been doing the last 35 years. However, over the last decade or so, I moved into high performance HVAC systems, and I'm pleased to say we're seeing some shifts, certainly in our Arizona market, on adopting some of the solutions we're going to cover throughout this webinar series, such as displacement ventilation and chill beam and decoupled hydronic strategies. As an educator, I just have a thirst and a hunger to really dig down into the details of things as best I can, and had a unique opportunity working with Fletcher Clark, lead mechanical engineer of Smith Group's Phoenix office, on co-writing 2 articles on debunking the myths on active chill beams that were published in Engineered Systems magazine. So anything that we can do to get good information out there so we can make more energy efficient, smarter, healthier buildings, that's my goal and my objective. Well, to give you an understanding of how this presentation all came about, as the pandemic began to advance and move forward in May, I was invited to participate in a webinar by our manufacturer of humidification products, DrySteam, on the physics behind why humidification reduces the risk of pathogen spread in the built environment. And it was such a good presentation, I immediately said, we've got to get this into our design communities, into our owner communities, so they understand why properly humidified spaces promote healthy environments. But when I began to think about it, I said, well, what does ASHRAE have to say about that? Well, I went to ASHRAE's website, and sure enough, ASHRAE had launched in April of 2020 their epidemic task force. And so it has been a terrific resource for me, because from evaluating the task force, I expanded upon the original concept of promoting humidification into the multiple guidelines that ASHRAE recommends for reducing concentrations of pathogen in the built environment. So I borrowed a lot of this material from ASHRAE's Epidemic Task Force. I really try to dive into the position document on infectious aerosols ASHRAE has published. And specifically, we're going to target today dilution and filtration. I also want to acknowledge our manufacturer of dynamic filtration for the resources they've provided on the filtration topic that we're going to cover. So today's agenda really is we're going to start, oddly enough, with somewhat of the political discussions that have been going on from the CDC and the World Health Organization on what are the means of transmission. I think it's important we have a common understanding of why perhaps people are wrestling with how best to move forward creating healthier environments. Then we're going to explore the ASHRAE's Epidemic Task Force website and how to navigate it, because it is very resourceful, but because of the density of its material, just thought that it would take some time to evaluate how to get the information you might need when you're at the site. And then we're going to look at ASHRAE's position document on infectious aerosols and on the topics of dilution and filtration. So with that, I'd like to begin with an article a friend of mine sent me at the end of August regarding how COVID-19 is spread. On August 25th, a professor, Luis Jimenez, professor of chemistry from the University of Colorado Boulder, published an article in Time magazine titled "COVID-19 is transmitted through aerosols. We have enough evidence, now it is time to act." In the article, Professor Jimenez goes on to state, contrary to public health messaging, I, together with many other scientists, believe that a substantial share of COVID-19 cases are the result of transmission through aerosols. The article goes on to elucidate the three means of pathogen transmission. There's fomitic transmission, surface to surface. There's droplet transmission in the near vicinity of some infected agent. Droplets emitted by that agent within the social distancing guidelines of 6 feet are direct means of transmission of pathogens. And then there is aerosolization, or aerosols, transmission through airborne viruses or bacteria is another way of transmitting pathogen. The article goes on to state, fomites and droplets have dominated our everyday understanding of COVID-19 transmission. While the WHO and the CDC both state that aerosols could lead to transmission under highly specific situations, both organizations maintain that they are less important. I believe this is a significant mistake. And on July 6, I, along with 239 scientists, appealed to the World Health Organization to reevaluate their stance. WHO updated their position in response, but the agency's language continues to express skepticism of the importance of this pathway. Well, interestingly enough, there seems to be internal pressures going on because the CDC, prior to earlier this month, had really focused its attention on fomitic transmission of pathogens as well as droplet transmission, but had not really addressed the idea of aerosolization of pathogen as a way of transmission. Well, that has been updated last week. If you go to the CDC website on the spreading of COVID-19, it states COVID-19 can sometimes be spread by airborne transmission. Some infections can be spread by exposure in small droplets and particles that linger in the air for minutes or hours. These viruses may be able to infect people who are further than 6 feet away from the person who is infected, or after that person has left the space. This kind of spread is referred to as airborne transmission. So the CDC is now adopting language to promote its awareness that SARS-CoV-2 or COVID-19 can be transmitted as an aerosol. And then Alan was good enough to send me recently, I think it was last week, Alan Anaya, that is, a press release from the office of Senator Martin Henrich, that Senator Henrich has now introduced a bill to Keep Schools Safe Act bill on October 1st to award grants. And he goes on to state that this is why I am introducing this legislation, to provide elementary and secondary schools with funding to improve air quality and ventilation. So what is ASHRAE's position on pathogen transmission, since our state and federal governments appear to be embracing the realization that aerosolization of SARS-CoV-2 can result in the transmission or spread of the infection? Well, in April of this year, ASHRAE launched a website called the ASHRAE Epidemic Task Force that can be found at www.ashrae.org. It is at that site that they have published their position document on infectious aerosols. And they also offer guidance for the reopening of buildings, design of new buildings, for filtration and disinfection to reduce concentrations of pathogen, also some guidelines for the transportation industry and other resources. Well, ASHRAE's position document on infectious aerosols, written on April 14, 2020, actually had been promoting their awareness that COVID-19 can be spread as an aerosol. And it states the risk of pathogen spread can be affected both positively and negatively by the airflow patterns in the space and by heating and ventilating and air conditioning and local exhaust ventilation systems. ASHRAE's issue statements that can be found on the task force website. The issue statement on relationship between COVID-19 and HVAC in buildings states ventilation and filtration provided by heating, ventilating, and air conditioning systems can reduce the airborne concentration of SARS-CoV-2 and thus the risk of transmission through the air. So the question is to get the information that ASHRAE has available to make informed design decisions on what to do with regard to not only new building, but perhaps even more importantly, existing buildings. What can be done with HVAC systems to reduce the risk of spreading of pathogens? If you go to the website, you will find this display. And be aware that you have to navigate on each topic in order to get to the material that you might be looking for. And there are many co-authors, so it can be a little confusing, and there isn't a common understanding throughout all the documents of all the terminology. So hopefully if I do my job today, I'll help make some clarifications on how best to interpret not only the use of the website, but also accessing the information you're looking for. So there you can actually attain guidelines on building readiness. You can get various other types of information, such as the position document on infectious aerosols and various other ASHRAE statements on COVID-19. Different building guides for schools and universities, multifamily, commercial, healthcare, et cetera, are all available through this display. But one of the things that I found, having been giving this presentation for the last 3 months, is that if you really look at ASHRAE's position, really all roads, all avenues come down to this one focused point, and that is, how do we reduce concentrations of active pathogens at the breathing zone of the built environment? And there are different solutions for doing that. So hopefully today, I will navigate through and hopefully distill, consolidate, and expand upon several major concepts that can be drawn from ASHRAE's position documents and their epidemic task force display to understand better what can be done to approach buildings that have enhanced dilution by using filtration, ultraviolet germicidal radiation, humidification, and all of the various technological resources we have to reduce the threat of active airborne pathogens in the built environment. So first, let us begin with ASHRAE's position document on infectious aerosols. The position document goes on to state that ASHRAE believes that these techniques, when properly applied, can reduce the risk of transmission of infectious diseases through aerosols. Chief among these ventilation-related strategies are dilution, airflow patterns, pressurization, temperature and humidity distribution and control, filtration, and ultraviolet germicidal irradiation. And throughout this webinar series, we will be approaching on most of these topics. The position document then goes on to state that according to the Bischoff 2013 and the Yan 2018 test findings, that pathogen dissemination through the air occurs when droplets and aerosols typically generated by coughing, sneezing, shouting, breathing, and talking. It goes on to state that small aerosols, which can stay airborne and infectious for extended periods, even up to days, can thus travel longer distances and infect secondary hosts who had no contact with the primary hosts. It goes on to state that while ventilation systems cannot interrupt the rapid settling of large droplets, they can influence the transmission of droplet nuclei and infectious aerosols. And it's important to really, I think, understand this fairly simple technological awareness of how particle size impacts the precipitation of a contagion out of the air onto surfaces in the immediate vicinity or beyond of an infected person. So a particle that is 100 microns, be aware a human hair can be anywhere between 60 to 80 microns in size. But a particle of 100 microns will stay airborne for approximately 6 seconds before it precipitates out of the air due to gravity. As you can see, smaller particles are more buoyant and they will stay in the air far longer. So if a particle or pathogen is ejected by an infected person into the space, the smaller the particle, the more buoyant it is, and the longer it will stay in the air. Well, a lot of this, yes?
Hey, Dan, this is Alan. Sorry. It's a quick question. So on an aerosol or out of moisture that comes out, do the droplets change in size based on space humidity? I mean,
absolutely. And we're going to be covering that in great detail in the next webinar, but you raise an excellent point. And let's just touch on it so it makes sense. When somebody coughs or sneezes, the virus that is released into the space is covered with an H2O envelope, shell, wall, because the human body is 65% water. Well, if the space is not properly humidified, that H2O wall evaporates, allowing that pathogen to desiccate and achieve its proper mass, which is 0.0125 microns in size. So yes, to your point, humidification affects the rate of desiccation or evaporation of the H2O wall, making the virus more buoyant. So in the position document then goes on to outline or lay out that and state that a droplet or particles of larger dimensions, such as 10 to 100 microns, they will precipitate out of the air within the 3 to 7 foot range of the infected occupant. However, ASHRAE states that the general dilution, ventilation, and pressure differentials do not significantly influence the short range transmission. Conversely, dissemination of smaller infectious aerosols, including droplet nuclei resulting from desiccation, can be affected by airflow patterns in a space. So ASHRAE is stating that for aerosolized particles of smaller size, the HVAC system can affect the concentration of pathogens in the space. And we see that displayed in ASHRAE's 170 guidelines for healthcare applications and operating rooms, where they actually use the air distribution systems to drive away any bacteria or any contaminant away from an open wound within a patient undergoing surgery. We actually use the air in that space to control the concentrations of infectious agent within the vicinity of the patient. So we know it's a proven technology to reduce aerosolized pathogen. The position document then refers to the Pantelic and TAM 2013 test that states ventilation with effective airflow patterns is a primary infectious disease control strategy through dilution of room air around the source and removal of infectious agents. However, it remains clear by how much infectious particle loads must be reduced to achieve a measurable reduction in disease transmissions. And this is the challenge. What is that threshold? Well, the effective means of transmission and infection is something of a subjective question, because do we have somebody who's a healthy 20-year-old, or are we dealing with somebody who might be older and have various health issues and their immune system compromised? Definitely, all of these factors are taken into consideration as to what level of concentration results in infection. So be aware, as ASHRAE cautions, even the most robust HVAC system cannot control all airflows and completely prevent dissemination of an infectious aerosol or disease transmission by droplets or aerosols. So there's no silver bullet. There's no magic that we can, or there's no technological magic we can use that will allow us to achieve that concentration threshold to a defined value. So we can only do the best we can to approach better indoor air quality. Well, one of the solutions for reducing concentrations is dilution. And we can actually allow for more dilution of pathogen in the space by increasing the amount of outside air to the building, measured in air changes per hour of that building. Or we can maximize in the event we are compromised on whether or not the existing heating and ventilating system can handle enhanced outside air volumes. We at least want to do what we would at least want to do is enhance the mixing in the occupied space to reduce concentrations of pathogen. So any questions regarding the political landscape that has transpired over the last 3 months on means of transmission? Any question on ASHRAE's position document on infectious aerosols or on the nature of their epidemic task force website?
So Dan, we have a couple questions in the chat.
Yes.
The first one is regarding the grant. Do you know when they will be available to apply for that grant?
I do not know, but Alan's been keeping close tabs on the development of this of these opportunities. Alan, do you have any awareness of that?
No, at this point we don't. It's kind of a follow-up thing that we need to really work on doing some research with Senator Heinrich's office to understand what status this grant or what status this bill is in. It was just introduced the first of the month. So, you know, I haven't had an opportunity to actually go through and review, to contact the senator's office to see what the status of it is at this point. That's on the to-do list.
Okay, so we can add this. I just made a note of it, and we will follow it, and we will make sure that we get the information out to everybody when we do have more information and details. because that's a great question. Oh, Elizabeth Hill is from the senator's office, and she just said the grant hasn't passed Congress yet, but the senator is working to get it passed with the next package. Thank you, Elizabeth.
Yes, thank you. That's good to hear. Kelly, was there another question?
Yes, Alan typed into the chat, how can we understand and measure the level of pathogens in the air?
I don't know that we have the sensing capability, and Alan, you chime in. I'm not aware of any device that can actually measure active living organisms within the space. We can measure volatile organic compounds, we can measure CO2, we can measure ion densities, we can measure, but I'm not aware of a device that measures various types of pathogens. Will it be germicide? Will it be fungal? Will it be viral? Will it be bacterial? So Alan, are you aware of any technology?
No, well, not that's realistic for a commercial application. But it's more of a making sure that people, I think, make sure everyone's kind of aware of, no one wants to be going into an office or a school that is, contaminated, obviously, or infected. We all want to do the best we can do at making sure that we're doing the best we can do to make sure the space air is healthy. And that's kind of really the end goal of this entire webinar series is, do what's reasonably possible and yet energy efficient at the same time to achieve a much cleaner indoor air quality than what we've done in the past.
Yeah, Alan, now that you mentioned that, we can sort of get an indirect understanding. I know that bipolar ionization, you can measure ion densities, and there's a direct test correlation by third-party test agencies that identify deactivation rates of pathogens at certain ion densities. So if you can, and you can, monitor ion densities in a building, you have every reason to believe that at that density level, a certain percent of effective, a certain percentage of active pathogens will be neutralized within a certain amount of time. And we'll be covering that in the next webinar in greater detail. Okay.
All right, one more question from Pat McMahon. The slide showed an energy wheel for outside air energy transfer. Will the wheel transfer the COVID particulate back into the entering airstream?
That's an excellent question. And in fact, ASHRAE's Epidemic Task Force has a whole section on energy recovery and what to be aware of. And that is a valid question to study. I have not done a deep dive on that section yet. It is one of my goals here in the future, but I don't have an immediate answer what ASHRAE's prescription is, but it is there and it's in depth. And I suggest that if you email me, I'd be happy to give you the direct link to that language.
All right, and that is it for the questions. If anybody has anything else, you can keep typing in there and we'll come back to them.
All right, so all paths lead to dilution. So how do we actually dilute levels of concentration in the built environment? Well, ASHRAE's section on dilution is the first and immediate way to dilute the air is bringing more outside air into a building. So ASHRAE's Epidemic Task Force, under their building readiness guidelines, first of all states immediately that to note that demand controlled ventilation, static pressure reset strategies, and the typical supply air temperature reset strategies should be disabled. So sadly, all of that inherent energy efficiency with these technologies will be lost because as you reduce outside air, you are not diluting the concentration of pathogens in that air for this simple reason. In order to maintain building pressure so you're not sucking outdoor air into your building, you have to exhaust almost as much air as you supply. And so the more air you exhaust, the more concentration of pathogen you get out of the building, which is a good thing. So ASHRAE is recommending that demand control ventilation solutions done through CO2 measuring or any static pressure reset strategies that reduces outside air be disabled. The building readiness guidelines then goes on to state that increased outside air changes per hour are recommended. The building guidance clearly encourages building operators to increase their system's outdoor air ventilation to reduce the recirculation air back to the space, and also to increase the amount of pathogen that is exhausted from the building to maintain building pressure. The guidance indicates that this must be done as much as the system and space conditions will allow. And here's the challenge. It requires a lot of energy and a lot of mechanical horsepower to condition outside air. And so it's a tightrope that has to be walked to understand what is available in the mechanical system to handle that outside air, and how do we make the most of what we have with at an affordable cost level. The building readiness guidelines then goes on to state the team should consider adjusting the space comfort set points to increase the system's ability to use more outside air. So if your building has a set point of 75, but you cannot maintain 75 if you increase the outside air, especially on a peak summer design day, then you may want to consider designing that room to 78 so you can increase your outside air and maximize the performance on your ventilation systems. Most buildings do not have the capacity designed into the air handling unit to adequately condition the air to the space. So hence, you might consider this strategy. Another way to optimize outside air is have your facilities teams look at the coils in the air handlers serving the space. Biofilm can grow, dust can collect, the coils can be congested. Make sure they're clean so there's sufficient heat transfer out of that coil that'll optimize its effectiveness on conditioning outside air. The building readiness guidelines also offers control strategies. I won't go into detail here, but it's very good strategies for controlling the chill water valve or even the hot water valve, certainly for the New Mexico environment, in order to optimize outside air and to get the most performance out of an HVAC system. So there are two options provided under the controls section of the increased ventilation control found in the building readiness guidelines that can help get the most out of the existing system. If you do increase your outside air, you're probably going to have some control sensors put into place to validate you're getting the quantity of outside air you need to minimize pathogen concentrations. We can provide airflow monitoring stations in the outside air and control dampers accordingly. We would need to look at the return air damper to make sure it can modulate in relation to the outside air to always maintain maximum outside air for enhanced dilution to a building. We would look at adding a discharge air temperature sensor off the cool chill water coil to make sure we're maintaining a design set point while maximizing our outside air. The guidelines under their building and space pressure wants us to be aware of what I've already mentioned earlier, that if you increase outside air, you're going to impact the building's overall pressure. And so you want to make sure that you maintain the pressure relationship of the building between the supply air and the exhaust air to the space. Otherwise, you could be pushing conditioned air right out the building or be sucking outside air into your building. And you also need to look at zone-to-zone relationships in the space to make sure you're maintaining proper pressure differentials, certainly where there are kitchens or any area that might be off-gassing, whatever it might be off-gassing. The position document on infectious aerosols holds this position. HVAC design teams for facilities of all types should follow as a minimum the latest published standards and guidelines in good engineering practice. I am approached regularly by engineers saying, Dan, what does ASHRAE say about what is the minimum air change rate of outside air to a building necessary? ASHRAE does not offer that. In fact, the only guidelines for air change rates that ASHRAE prescribes is for hospitals in ASHRAE Standard 170. They do not offer that information in other facilities. So it's right now, ASHRAE is advocating provide a minimum of outside air per ASHRAE 62.1 guidelines on ventilation rates, and then try to do what you can to enhance that amount as much as you can in relation to the existing HVAC system and what load it can possibly bear. Well, what about the dilution to the mixed air in the space? What if you are challenged to provide more outside air into your building? The minimum of what you want to do is maintain mixing in your building. The goal of a mixed air system is to supply air at high velocity to the space so that you cause room air to be induced in the supply air jet, so you create a uniform temperature in that space. However, most systems, especially institutional systems, are variable air systems. So though we can guarantee the outside air at a space when your system is at 100% of flow, if your system is at 50% of flow, 60% of flow, conditions that you would see normally during our periods of year when we are suffering from influenza, cold viruses, and whatever, during our autumn and winter months, then of course we have a reduction of airflow to the space. We have a reduction of room side mixing, and you run a greater risk of creating pockets of higher concentrations of pathogen in various parts of a room. So be aware that you want to make sure on the air handlers, if you are going with an outside air return air strategy, you have the modulating dampers necessary in your air handler to control the amount of outside air to the space, and also to make sure that you do what you can to maximize the amount of mixing in that space available. We do have a technology to do that. It's relatively affordable, and we'll be covering that in the third edition of this webinar series. And all of this is important and can be studied in greater detail in Taylor Engineering's new white paper issued on October 14th. I haven't had a chance to study it yet, but I will be looking at it very closely over the next week and hopefully have some new information for next week's presentation or the following 2 weeks. Anyway, in the document, it references the Guangzhou restaurant study in China, where they had documented an asymptomatic carrier at table TA in the very top of the right-hand graphic. He was at dinner with friends for 1 to 1.5 hours, talking, laughing, speaking loudly, thereby injecting droplets and aerosols into the restaurant. The HVAC system, however, was inadequately designed and was only offering 1.6 CFM per person. So that is 10% lower than the California minimum code. So if you don't have sufficient ventilation in the space, you run the risk of aerosolized transmission of the pathogen. So it's quite an interesting study to read. So we want to do everything we can to maintain or to maximize the ventilation to a building. And ASHRAE's Epidemic Task Force has guidelines for doing that. And we certainly want to optimize mixing conditions in the space to prevent pockets of enhanced concentrations of pathogen from developing when we're at part load conditions. ASHRAE's building readiness also offers a pre and post occupancy flush strategy. So we can actually open up the system during the nighttime hours when people are not in the office and just flush the building out. ASHRAE has a recommendation of 3 air changes of outside air per hour in order to properly flush out any pathogen that might build up during the occupied times. So any questions on this? Kelly, any questions?
Yeah, sorry, just trying to find the unmute button, you know.
Ah.
So we have a couple questions. Alan said, are we not in somewhat of a medical situation to minimize pathogens?
Could we repeat that?
Alan, I don't know if you want to elaborate on which slide.
Yeah, and it really ties into the only place where ASHRAE recommends, it has an air change rate recommendations for healthcare. And so that being the case, does that not, are we not real, should we not be treating our spaces similar to healthcare application when we're trying to determine how many air changes do I need in order to keep the space as clean as reasonably possible?
Well, that's an excellent question, Alan, and I can't help but think from the psychology and the efforts ASHRAE is involved in, that they are probably moving in that direction. But again, there are many different healthcare room usages. I mean, there's operating rooms, isolation rooms, patient rooms, all of them have different air changes. So what is that air change? I heard the idea of maybe 2 air changes per hour being adequate of ventilation air. That's a lot of outside air. So it's going to beg the question of reevaluating the existing system in order to meet that idea that has not been substantiated. It's only been discussed.
All right, so along the same lines, so Micah had also asked, what is the recommended air exchanges for a medical institution as a benchmark that we can compare it to? So you just kind of covered that one. And then also Tony Sparks had said, is the unoccupied building flush 3 total air changes or 3 changes per hour for the unoccupied?
Good questions. First question, I think I already touched on to some part. An isolation room in a hospital is designed to 12 air changes per hour. A patient room is designed to 6 air changes per hour. So, we're talking about perhaps 2 air changes per hour being considered. I think I hope that answers the question. That just gives you some understanding of the magnitude of air change rates we would be dealing with. To give you some context, an operating room calls out for standard 170, 20 air changes per hour. So I think that we would find somewhere in the realm of 2 to 4 air changes perhaps might be considered, but only after we have the data that would substantiate that prescriptive value. Now, with regard to 3 air changes, that's a good point. I said air changes per hour out of habit. They probably mean 3 building air changes per the time we're in the unoccupied mode.
Okay. Jasmine asked if this information could be provided via email. Yes, we are recording, so we can share that. And Dan, possibly we could share a PDF version of your slides and also these questions.
Absolutely.
Okay. Brandon, if we commit to nighttime flush periods that may cause issues with building temperature recovery during occupied hours and peaks and lows of cooling and heating seasons, would we build this into design capacities?
Absolutely. In fact, ASHRAE touches on this, that you would consider going into your morning cool down mode or your morning warm up mode, maybe an hour to 2 hours before occupants start coming into the building. So yes, ASHRAE has some language addressing that very design consideration.
Okay, there's also 2 links. I'm not sure the name because it's looks like first, initial, last name possibly. Provided a link in the chat for lower tech particle counter concept for surge isolation rooms, so people can look at that and review it later. They also provided a link for AC in medical facilities from the CDC.
Excellent.
So 2 good references there.
Thanks so much. I appreciate that.
And then let's see, we have one more question. Cliff, what is the typical MERV rating of filters in air handling units in centralized HVAC systems?
The design standard typically for commercial buildings is MERV 8.
All right, that is all of the questions for now.
All right, then let's move on to that topic, filtration. So for filtration, how does ASHRAE address minimum standards for filtration? Well, first of all, they had to create a standard to make sure all manufacturers conformed to the same testing methodology. And so they built standard 52.1, now 52.2. It was changed and updated or upgraded in 2009, I believe. And it is called the Particle Removal Efficiency and Testing Standard. And the standard describes a method of laboratory testing to measure the performance of general ventilation air cleaning devices. The standard also defines a method for counting airborne particles of 0.3 to 10 microns in diameter upstream and downstream of the air cleaning device. It also defines a term that is called the minimum efficiency reporting value, otherwise known as MERV. We hear that all the time in our industry. What is the MERV rating on that filter for its particle removal effectiveness? The standard goes on to say that MERV identifies dust holding capacity, that is to say, the total weight of synthetic loading dust captured by the air cleaning device over all of the incremental dust loading steps. And it expresses efficiency as a function of specific particle size. So particle size efficiency is known as the PSE. The standard identifies three groups, E1, E2, and the E3 group, comprised of various groupings of particle sizes. It then goes on to define the effectiveness of different MERV ratings on removing particles of the stated sizes. And it provides a chart. So it was mentioned, I was asked what type of filter do we normally see in commercial applications? And I said MERV 8. Well, you can see a MERV 8 filter for a range 1 particle of 0.3 to 1 micron. It's not available because it's ineffective for that particle size. You can see some effectiveness at range 2 particles where it will remove 20% of particles between 1 to 3 microns in size. So this is how the chart is used. Well, ASHRAE's Epidemic Task Force in the Filtration and Disinfection Guidelines addresses these groupings of various forms of filtration. It addresses mechanical air filters. It discusses high efficiency particulate HEPA filters, electronic air filters, gas phase air cleaners, in-room or portable air cleaners. It goes on to define which MERV ratings are most effective for removing pathogens. And it states categorically that MERV 13 or greater is efficient at capturing airborne viruses. However, it does say MERV 14 is preferred. And it does evaluate high efficiency or HEPA filters as well. But due to the resistance of HEPA filters, the added static pressure loss, should it be applied in an existing system, is somewhat prohibitive. You would have to reevaluate perhaps your whole air handler configuration. Well, what does filtration have to do with SARS-CoV-2, which is a particle of 0.125 microns, substantially less, half the size of the 0.3 microns stated in the ASHRAE standard 52.2 guidelines. A MERV 13 filter is 50% effective in arresting a particle of 0.3 microns. So it's only 50% effective, so be aware of that. Again, we're dealing with the laws of diminishing returns. This is the best we can do with what capacities we have in the air handlers in existing systems. But again, you're still substantially short. if you're at 50%, meaning 50% of SARS-CoV-2 and arguably far more because of its reduced size, will get through even a MERV-13 filter. So ASHRAE does recommend MERV-14 as the preferred value, if not more, if the system can support it. Be aware, if you do provide MERV-13 filtration in an air handler that is currently served by a MERV-8, you're going to see an enhanced pressure drop. You're going to see a pressure drop of 0.38 when the filter is clean. How long does it stay clean? It's going to load up. The more particulate loads the filter, the more the static pressure loss. And you need to make sure you have the fan horsepower necessary to overcome that increase of resistance due to the loading of MERV-13 filtration. ASHRAE's task force provides this.
Dan,
Yes, Alan.
Sorry to interrupt you, but
No, not at all.
of those on this webinar who have already changed their systems to from a MERV-8 or even a MERV-6 to MERV-13, I'm curious of what they're seeing as far as increased maintenance timeframes. In other words, are they seeing needs to have to replace the filters every month versus every quarter? So those of you who are on the line that are owners or maintenance, just in the chat section, kind of make any comments of you're seeing change going from MERV-13 filters requiring a tripling of maintenance frequency or a doubling or whatever the case might be. So as we go through, if you just put it in the chat, I'm curious.
Well, Alan, that's an important point, because if you do move towards a MERV-13 filter, are you getting the airflow? And if you're not getting the airflow, you're not getting the heat transfer on the coil, which means you're not going to get the temperature set point in the building. It's a domino effect that we all need to be aware of. And that's why ASHRAE raises the points and making sure that your coils are clean, looking at control strategies or whatever, because this is a challenge, but it is to increase the filter efficiency makes all the sense in the world. But there's, again, you can only do so much with what's available, and there will be an impact on your system. So in the mechanical air filters section of the task force under filtration and disinfection, it says that depending on the filter efficiency that you can achieve, it'll give you a graphic and a guide or a graph to demonstrate the fractional efficiency of particulate or pathogen removal based on the particle size, based on the MERV filtration. And that's what these numbers are. Here's a MERV-8 filter, here's a MERV-13 filter, and you can see 0.4 or 50% or less than 50% fractional efficiency at particle size of under 0.2 microns. So it's a very effective chart to give you some evaluation of the efficiency of various MERV rated filters. The task force goes on to specifically address HEPA filtration, and it states HEPA filter efficiency is better than MERV-16. HEPA filters may not be an appropriate option for some HVAC systems due to high pressure drops and the likelihood that systems will need new filter racks. Absolutely. Can the air handler or the package DX unit support that? And the answer is no. Also, for a HEPA filter to function properly, it must be properly sealed and maintained. If there's any gap at all in the frame of the filter or between the filter and the frame, a lot of contaminant will side stream bypass that filter, and it'll cease to be effective. And when installing them and dealing with them, you have to be very careful not to put even a fingerprint on the exposed media, or it will compromise its performance. High efficiency our HEPA filtration can be 99.97% efficient at filtering particles 0.3 microns. But again, SARS-CoV-2 is 0.125 microns. So really, where do we go with this? So HEPA filtration is ideal but it's not a realistic solution for most commercial applications in our industry. So the building readiness guidelines in the task force also addresses practical approaches for increasing MERV values in air handlers. I invite you to go there. We don't have time in today's presentation to evaluate that. But also be aware that the systems under the commercials tab in Article 5 under general, it states that if there are significant energy impacts to a building, then use ASHRAE's minimum outside air ventilation rates defined by ASHRAE standard 62.1 and incorporate MERV 13 filtration as a minimal, and you'll have some abatement of concentrations of pathogens in the built environment. It also goes on to state that you want to update and replace your existing HVAC air filtration to a minimum of MERV 13, again, if at all possible, and always make sure your filter seals are properly sealed to prevent bypass and loss of effectiveness of the filtration device. Please know that as you increase the filter efficiency, as I mentioned earlier, you're going to have an increase of air handler horsepower. To evaluate that in our industry, we can look at using the fan affinity laws that will help us to calculate the new brake horsepower we can project by increasing the static pressure in the system by adding enhanced filtration. Please be aware if you do that, we just took a small fan, 2000 CFM, maybe for a packaged rooftop unit, and we did an evaluation of a fan supplying 2000 CFM at 1/2 inch of static pressure. We have an operating brake horsepower of 0.38. If we increase that to 0.8 by inserting a clean MERV 13 filter, our brake horsepower now jumps to 0.51. Now, as the filter loads, that horsepower will increase. You'll have to change out your motor to a 3/4 horsepower to allow it to adapt and perform when you enhance the filtration to MERV 13. If actually increasing the air handler horsepower and upgrading your filtration is not really realistic regarding the size, scope, and current installation of HVAC system you have, there are technologies we're going to cover throughout this series that will allow you to have agglomeration occur of particulate in a building so that your filters can be more efficient and there are enhanced ratings achieved without adding to system static pressure. Any questions?
All
Just-
right, we've
Oh.
got quite a chat going here about the filters.
Yeah, I had a question. Why did you choose adding 3/10 of static on your example? What was your baseline filter?
It was a MERV 8 filter. Putting in a clean MERV 8 filter roughly will add about 3/10 of an inch of static pressure.
Okay, so I will go through these. So Tony Sparks, where we have MERV 13 at APS, we find we change them 2 to 3 times more often than MERV 8. Stella Lavis, MERV 11 filters were installed at our school. Should we request MERV 14? The building is 61 years old.
The question is how old is the HVAC system? And we would an evaluation would have to be done to see if there is the fan horsepower available to handle that increased static pressure to MERV 14. If a retrofit has been done in the last 10 years, there might be that opportunity there. It would have to be evaluated.
Yeah, and this is the common thing that we see, that many of our systems and many, not just schools, but our office buildings as well, the HVAC system may not accommodate a MERV 13 or MERV 14 filter. So as an owner, whether you be a school superintendent or whether you be a building owner, what are your options for providing maximum filtration, ensuring that you're doing what you can for your occupants to make it healthy? And just going in and replacing your HVAC system in most cases is not realistic. So that's when we really get into the other technologies that we'll be covering in the coming up sessions as well.
All right, so there are quite a few questions. So if you do have to jump off because it is noon, we understand. I'll keep going through these. So if
Kelly, can we pause for just a minute for those who have to
Absolutely.
jump off?
Yes.
Please be aware that next week we will be looking at some of these solutions that will reduce concentrations of pathogen without adding to system static pressure of an air handler. We're going to be covering humidification, UV technology, and bipolar ionization. And on the third session, we're going to be looking at integrated HVAC solutions for both new construction and for retrofit applications, blended approaches, what they are. They're innovative approaches, some of them, but we want to bring them to the markets for you to be aware of and to evaluate. So if you have to jump off, thank you so much for joining us today. And I'm here, I can stay to answer any other subsequent questions that we might have.
Perfect. Okay, so I'm going to go through the rest of this chat. Also, if you do have to jump off, not everybody has their name, like their full name, when they signed in. So for tracking registration, if you do need PDH credits and your name is not obvious to me to be able to figure out, like if your last name or something's not in it, go ahead and send me a message and just let me know that you were on today. Also, if you only joined us through your phone and not the computer, it shows your phone number. So go ahead and send me a message as well, letting me know. That way I can track your attendance for the swag bag at the end, and also if you do need the PDH credits. All right, so we'll keep going through this chat for anybody who wants to stay on. Pat McHannon, he asked, is the size of COVID the same as SARS?
Very similar. I don't know the exact reading. In fact, I don't even know the exact reading of SARS-CoV-2. I've heard 0.1, I've heard 0.125, which seemed to be the most consistent. I've heard 0.15. And I know that most viruses fall in that same particle size.
Yeah, you know, and I've seen a graphic, actually, I'll have to find it that we can share, that shows a bunch of different viruses and their sizes, also along with normal particles that we're used to, that kind of breaks down and shows you just how small it gets. I'll look for that graphic.
That'd be great, yeah.
Okay.
Would you share it with me, Kelly?
Absolutely. Let's see, John Anthony, we're seeing with 2 of our clients reduced time between filter changes to a half or about 4 to 6 weeks in lieu of quarterly or every 3 months. So Alan, as you thought by asking that question, they are being changed more frequently now. At McCurdy Charter School, we're told that the new MERV 13 needed to be changed once every 2 months, as opposed to the every 3 month change with the MERV 10 we were using before. Alan, isn't filter installation minimizing bypass with every filter? I don't know if Alan wanted to.
Yeah, that was, so Dan, back on your slide about HEPA filters and the importance of the installation.
Yes.
Really, that the next one, oh, it's not, there you go. So the next to last bullet point there, to function properly, HEPA filters must be sealed. That really applies to any filter. HEPA filters a little bit more because the particles are so small that they're trying to filter, but really any filter needs to be properly sealed in order for it to function as designed.
You're absolutely correct. In fact, in a lot of existing buildings, Alan, we find that one of the biggest challenges is making sure that filters are being changed out regularly,
Right.
let alone HEPA filters.
Yeah.
I think people change out HEPA filters a little more because they are pricey and they understand the consequences of not doing that.
All right, Aaron Aguilera said there was a recent development in July by the University of Houston to come up with a heated nickel foam HVAC filter with 99% catch and kill effectiveness. Do you have any insight to that technology or any developments from that?
I do not have any awareness of the technology and would love to learn more about it.
Yeah, that's the first I've heard of it. Alan?
I had not heard anything. But we'll put it on our list to do some research on to see
Yep, absolutely.
Yeah,
what's there.
All right, let's see, Jonathan Dooley will attend us receive the slides. Yes, you guys will. John Anthony, why do you, oh, he already jumped on and asked that question. Daniel, I believe Camphil has some good information on filters for your customers. I believe they do as well.
yeah.
Yeah. Rick, good day, everyone. I will see you next week. And let's see, Ian, how can we account for the unregulated air pressure going around the filter in the event that we assume that not all air filters are completely sealed?
I don't know. It's a great question. And the problem, what it really gets down to is training of the people putting the filters in and getting them to understand how critical it is that they be installed with care. Whether you're putting a MERV 8 in or a HEPA filter in, the same care needs to be taken and ensure that it gets put in and it's a snug fit that minimizes any potential bypass. I don't know that you can really, I don't know that there's a real way to account for it.
Yeah. Tony Sparks commented that the availability of MERV 13s right now is a big issue.
Yes, it is.
I'd heard 8 to 12 weeks. Is that realistic?
Yep. That's what I've seen as well. So, and that's, and this is where, for I think particularly for our schools, for offices as well, that, we're trying to get people back to work, back to school is, you're not going to have filters for 12 weeks. Well, guess what? That's for a school. That's a huge problem right now to get kids back in school. And I think this is where the technologies also come into play of saying, hey, we can provide some significant increases or improvement in our air quality without having to go to the expense of the MERV 13 filters, much on the operating expense because of changes in horsepower, much less material.
Yep,
Correct.
and that is a perfect segue into our topic for next week. And that was all the questions. Brandon did provide a link to that study from the University of Houston, so we can take a look at that.
Thank you.
And Kelly, just to re-clarify, we're going to take all these questions, comments, and include these with the answers to all the recipients, correct?
Yes, absolutely. So we'll
Okay,
put all that.
that way everyone also gets these links that have been sent over, which are greatly appreciated.
Yep,
Yes,
absolutely.
thank you.
Yep, I'll put all that together, make sure that we have the answers to the questions. We'll share that along with a PDF version of the slideshow, and I will provide a link to the recorded webinar as well.
All right. Thanks, everyone. Have a great day.
All right, thank you.
Thank you very much. Have a good
Thank
day.
you
Stay well.
so much.
Bye-bye.